Welcome, everyone. Welcome to this seminar by the Space Center of Excellence about continuous integration. My name is Gerrit Kalademir. I am a researcher at the Ludwig-Maximilian University in Munich. And me and Christian Katlubiak, who's from IT4I, he will going to tutor or host this session today. And the aim of the session is, first of all, to really give a beginner's guide for everyone who's aiming to adapt some sort of continuous integration pipelines or something like that to their code using the GitLab environment. And then also as a second step, and this will be Christian's main thing, how you would set this up in an environment of like a supercomputer, like one of the IT4I systems. So this is the kind of goal that after this session, you have like a good overview, very good starting point on how to set these things up. Yes, so just a quick overview. So the first part, which I'm going to talk about, is about general usage, kind of like a short introduction, why you should do CI/CD or continuous integration, continuous deployment. Also, how you install, how you create, how register so-called GitLab runners, how you create a simple pipeline with GitLab. And then also I will go through a bunch of options, which I think are very handy, which can be very useful when you set up your own pipeline. And I will display this and I'll show examples from the OpenGadget3 pipeline, which is we are running. And in the second part, Christian is going to look at the specifics of how you would do that on a cluster, how to set these things up. So the technical requirements you need for setting up a pipeline, how you can run your CI pipeline using Slurm jobs, how you can integrate this with Slur, and also, of course, we will talk about common pitfalls and best practices, all the stuff that we stumbled across. So let's get started. So beginner's guide to continuous integration. First of all, we want to answer the question, what is continuous integration? So the idea behind this is that I just took a sentence here out of the dictionary, actually, which I modified a bit. Continuous integration is a practice of merging all your code changes to some sort of main line or main branch, depending on the language you prefer, and that you do that early and often. So this is one key ingredient, that you don't merge every 6 months when you have modified the whole code, but you do that incrementally. So whenever you have some updates, you merge them to the main line. And now the second part is that this merge is combined with some sort of automated testing for each case. So that means that whenever you change something in the code, you automatically, or ideally, of course, automatically run some tests on the new version of the code just to make sure that it's still functioning properly. Good. So why is this important? So yeah, why should we do all this, put all this effort into setting up this CI pipeline and things? So the first thing is simply that if we merge frequently and if we trigger testing, we simply reduce the potential for issues in the code quite significantly. And we will able, and therefore we are able to find any errors or mistakes much earlier in the development process. So we find any bugs and stuff at a level where only small changes has happened and not 2 years later where the code has changed completely and we are then having a big issue trying to figure out why certain modules are not working anymore as expected. This, of course, speeds up the whole development process quite significantly. Of course, first of all, like compiler problems you can find them very easily, but also all the other things. So it just gives you a very nice tool, a very handy tool to check your code on a regular basis and makes your life much easier. So we'll go over this very shortly because usually we will focus on the CI part and not so much on the delivery. So when you have your CI/CD pipeline, how it's usually called, the first part is this continuous integration. So you can like test every update you do on the code, and the continuous delivery is then kind of like the approach which you would do when you would apply your code or how you would give it to your users. So in this kind of case, you can do this automatically as well. So of course, a lot of us know that we usually do release code in like big settings, let's say. So this is version 1, version 2, version 3, and so on and so forth. In a continuous delivery approach, you would do this more on a smaller level. So you would really update code not on a large scale, but really sometimes like you really fix very small bugs, and whenever you fix something or implement something, you would kind of like release this immediately so that people kind of like update their code very, very often. So they're always up to date. And this, of course, can be done automatically as well. So in this kind of like pipeline here, you kind of like test the software, your code on a system and an environment which you think the user would use, and you make sure that all the functionality is still there. So like a production-like environment, and you don't have to do this manually, like a big testing at the end. And this approach, of course, kind of like can reduce cost and time, and also the risk of delivering changes because you allow for more incremental updates and not these large steps. But for this talk, we're going to focus on the continuous integration part and not so much on the delivery part. As I already mentioned, this term pipeline. What is a CI/CD pipeline? Generally speaking, this pipeline or CI/CD pipeline is just framework which automates the whole process of creating, testing, and deploying the application. And as I already said, and I can't stress this enough, is that an automated way of setting up a pipeline, this really reduces the risk of any errors and mistakes in the code, and it really makes you find bugs very, very early, which makes, of course, the fixing much, much easier. So yes, let's get started. What do we need? I mean, everything sounds great in theory, but when you get to practice, it might become a bit more difficult. As we focus on GitLab for this, there are other ways of doing CI/CD as well. So maybe some people have heard about Jenkins, for example, which is a tool. You can also actually combine it with GitLab, but the nice thing of GitLab is that it has everything integrated. So you don't need any additional software or anything, any extra tools, which makes also the maintenance of the code much easier. So what do you need? First of all, of course, you need a GitLab repository with some code you want to test. I think that's pretty clear. And secondly, you need some sort of system to run the tests on. So this can be anything, like your local your personal laptop in case. It could be any kind of like Linux cluster you have at your institute or in your basement. Or in theory, it can be a supercomputer like the ones by IT4I, which Christian will talk about later. Very important here, and understandable, but pretty clear. The system, of course, must be able to run your code. So it needs to have the modules, the libraries, and all these kind of things and requirements, and also the number of cores you might need, and the amount of memory, and all these kind of aspects. I just want to mention this here as well. And then, if you have these two requirements, of course, you need one more thing. These are simple test cases. So you have to think about your code. What are the cases, or what are the things you would like to test it? So one very simple step is, of course, does it compile? That's, of course, the easiest and most straightforward test, but also very, very important. But then also you can add a lot of other tests, like unit tests. You can test some sort of, you have to maybe test cases like, we will later use some hydro shock waves and stuff like that. So where you have an analytics solution which the code has to reproduce, for example. And so these are kind of like tests which you can use, which are different to each code. And you have to think about what are the things you might want to test in this kind of environment. Maybe you have already a benchmark or reference, like an old version of the code where this result is correct and it has to be reproducible. So you kind of like rerun the test with each new version, and it still has to give the same result. So these are the kind of like 3 requirements you will need to set up a CI/CD pipeline. Cool. So what do you need to set up the pipeline? I will just go through this here now in a few bullet points. So the first thing is, of course, that you need to set up the workers, because you need something which executes the code at the end of the day. And these are the so-called GitLab runners. So, of course, you need to install them on your system. and you have to create them and you have to register them. No worries, I will go through this in more detail in a few minutes. Then as a second step, if you have your runners going, so you have a way of running code on your machine, on your system, you need to create like a process script, and this is a pipeline, which tells the runners what they have to do. And yes, we will go through this, how you create a pipeline, how you schedule a pipeline, and then we'll go through like a lot of options which you can use in order to modify your pipeline. And then, of course, if you have all of this, you can just run your jobs and check your code on a regular basis or whenever you feel like it, if it's still doing what it's supposed to do. So, quick introduction about how you would install or create your runners on your system. I already mentioned it. Runner is essential in GitLab, because that's kind of like the application or like the framework which works with GitLab to run the job at the end of the day. And it really allows you to run jobs on any kind of machine, and you can therefore connect your machine, your system, as long as it has an internet connection, of course, to the GitLab repository. So yes. To do so, of course, you need to install the GitLab runner software on the system. I put the link here. It's pretty straightforward. You can just do this via command line as you used to. So it's just a piece of software which you have to install. And one thing which I want to stress here, which is really, really important, is that you always install the files from the link above and not with the usual apt-get and so on tools, because the issue is that with apt is that this version is highly outdated. It will probably work, and it will work for like 80% of everything you want to do, but there will be specific cases or rules and variables and stuff you will later see in your pipeline, which the old runner is not able to understand. So you will have limited options and what you can do with them. So I would definitely recommend that you always go to the website and install the newest version, or to even be more precise, that you install a version which is the same as your GitLab version. So GitLab as well, even though it's a web page, has versions as well, and you can find them by just put the link here, put GitLab, and then, for example, your name, depending on how the web address is, and then /help, and then it tells you about the version, and I really recommend trying to find the corresponding runner version as well, because then the GitLab itself is providing you with the tools that the runner is able to execute, and so on and so forth, so you don't have any mismatches here. So please don't just go through and apt install everything. It will probably work well and for 80% of what you do, but it will cause you some headache maybe at some point. So how would you do that? I will show this here now for one of my test repos, and I will click through that later on one more time, but I don't want to set it up because it might take a little bit of time, and I don't want to do that here now in live, but I want to show you how this is done. So in your repository, there's a CI/CD section, which you can see here. I will show you later one more time. And there's very simple that you highlighted here in red that you can create a new runner. And what you can do is you can always create a runner which you assign to a certain project or a project group. So kind of like for all the repositories that you are a member of, or you can also just create a runner on a system. Sometimes there are already runners available on the system, which you then just can pick and say like, okay, don't need to set up my own one. There's already in the system I'm working, there's a certain number of runners available. I just pick this one, and this one will be then the one which is going to execute all my tasks. So this way you can also share runners across multiple projects, because sometimes it might be useful and not having to set up a runner for each individual project. Also, this is important in case you have some limitations in your system, because if 10 runners want to work at the same time, but your system is not large enough to host all of it, this will cause some problems as well. And this way you can kind of like also make sure that you never run out of memory and these kind of things. So when you click on that, it opens a new page, and you can say what kind of system you have. Do you have a Linux, a Mac OS, or Windows? If you need some kind of containers, if you want to provide a tag, so that only specific jobs are allowed to pick this runner. One simple thing would be, for example, you have a runner which is there for GPU tasks or tests, and you can tell it, okay, only jobs which I have to tag GPU are allowed to run with this runner, which then makes sense because that runner might run on a different system, has different modules and all these kind of things, which are then streamlined to run GPU tasks, and therefore you don't want to send any CPU-only job to it. You can also, of course, give it a description and a few other settings as well. But of course, you can also say that it can run untagged jobs, so it just picks everything which is kind of like untagged. When you decide on that, you have to register your runner. GitLab nicely provides you with the kind of, hope you can see my cursor, with the command, which you have to then put on in your system. So it gives you the URL. So I'm working at the LZ at the moment. So I'm showing you the LZ. It gives you a token. And with that, you can register your runner. The runner will then ask you a few questions, because it will then ask you what kind of executor is supposed to work. Do you want to what do you want to do with that runner? Do you want to establish an SSH connection? Do you want it to function like a shell or any kind of Docker? You can also create a virtual box with it, Kubernetes, Perls and stuff. There's a lot of different options depending on your code, which you can specify your runner to how it should behave. And I put the link about the details there as well. And when you see all of that, here we go. Yeah, you have your runner registered. Just one more time, GitLab also tells you how to install the runner, but don't do that because it will install an outdated version. So it will tell you everything, and it's really, really nice. I don't know how it works for Windows, but at least for Linux, it gives you a very, very outdated version, which doesn't have all the functionality which you might want to use, just as a warning. Cool. So when we did that, we can also check on our system if the runner is working. So we can check the runner list. So here in the first, we can check how many runners are on the system. Here we have our OpenGadget runner, and we can verify the runners as well. So it provided me with some warnings. Sorry for that, but yes, and it tells you the runner with a certain naming is valid or not, and this already tells you a little bit about it. On the other hand side, you will see that in the GitLab repo as well. So you kind of like can check from both sides if both sides are okay with the runner and if the connection works as intended. And I definitely recommend doing this, at least at the beginning once, just to make sure that everything is working as planned. Cool. So this is kind of like a short way of how you would set up a runner. Next step, of course, then will be that the runner is supposed to run something. So it's about how to set up a pipeline. And this I will do like in a hands-on version. So I'll show you everything one more time, but in this time, I will show you this directly in GitLab at a test repository, which I created for this occasion. So probably most of you have already seen this environment. So this is the page or the GitLab page, this time from the LSZ. And you have here the kind of like personal stuff. So my icon and some to-dos, which I have to do, which I will probably have to do later on today. And you have here your repository information. This repository moment is completely empty. It just has the standard README file and nothing else. So we now want to run or want to do some CI/CD, right? So, and if you now just have a look here in code, plan, and the options which you have here, you see there are no pipelines or no CI options. This could be very simply because in most cases, CI/CD is initially deactivated. So before you have to search along, first check the settings, go to General, go to this visibility features and permission section, and then you can see here CI/CD. When you see it's deactivated. So this just make sure that this is activated. It will save you a lot of time searching, trying to figure out where it is, because, yeah. So yeah, just activate this here. And you can go down until you can save the changes. As you see here, is this CI/CD catalog project. This is in beta version. We will leave this off at the moment, but this is an option in theory where you can define kind of like templates for the pipeline later on, which maybe makes it easier for your collaborators if they have to or want to set up a new pipeline or new jobs and all these kind of things. Good. So now we have activated the CI/CD option, and now you can see that this build option here appeared. And you can see you have now pipelines, jobs, pipeline editor. So if we go on pipelines, you see there, of course, there are none so far. We haven't run anything, but you can see already that it provides you with a lot of different templates and options which you might want to investigate depending on your code, because it will tell you, give you a lot of different environments with just suggestions what you can do and how you can set up a runner with C++ or whatever kind of code you have. So this just to keep that in mind, that GitLab provides with a lot of templates and a lot of already information where you can have a look how people maybe did similar things which you're aiming to do. Okay, so as there are no pipelines, we will have to create one. So just go on pipeline editor. And yes, it tells us that there is no editor yet. And it already tells us that it will create a YAML file. So as you can see here. So pipelines are always saved in this YAML files. And usually in your home directory of repository, you have this GitLab CI YAML file, which is kind of like the main file where you store all your pipeline commands. And so as we don't have one, let's create one. Cool. So this is now how it looks like. It has created a YAML file. And what's really nice about it is it already created us some sort of template. So it didn't just create an empty file, but it created a template file. So with some sort of, arbitrary or like template, a pipeline. And we'll go through this now in a little bit of details because it already gives us some information about the syntax and what we can do and what we have to do. And then we can have a look what this pipeline is actually doing. So this pipeline has different stages. Now build, test, and deploy here now. And each stage consists of at least one job. So for example, you have the stage, first you build the code, then you test the code, and then you deploy the code. That's the idea behind this. Let's have a look at how the build job would work. So this is this here. So this is the job name. So build job. Stage tells you when it's going to be executed. So in the build stage, so right at the beginning. And then what it's going to do. And the nice thing is here, as we set up runners, which work as a shell environment, you can simply use your script as you would do when you type on the command line. So you can kind of like build your own script here. In this case, of course, it only gives you some output. So it just tells you compiling code, completing the code without doing actually anything. But nevertheless, this will just be some print statements. But you can add here a few more lines and do all the things you would do on your command line to run your code, to run the test or anything you could think of, or to load something, load modules, create environments, install software, etc., etc. So just everything you would do on the command line as well. Cool. So that's kind of like for the build, and then you have for the testing, we have a unit test, which does a similar thing. It gives some output, waits a while, gives another output. We have a second test, which is again gives some output, waits a little bit, gives another output. And then we have the last job, which is for deployment. It here has a specific environment, even though this one is not existent in that sense, but you can specify a certain environment. And again, it just prints some output. But we go into more details later. We just use this one here and say, okay, we're fine. We want to use this this pipeline. And one thing which is really nice, it already tells us if the syntax is correct or not. So in case we are editing it here, it will already tell us if there are any typos or anything like that. And it, as you can see as well, it already started the pipeline, because at the moment it does this at every push. So whenever you change something, it will automatically start the pipeline. So let's have a look at it. We can click here now on the pipeline, but we can also go via pipelines. So just that I will do it this way, because now you can see that here you have the pipeline. It gives you some status. It's pending at the moment. It's the latest version of the code, and it tells you that it's stuck. We're going to look at this. It also tells you that I created this one, and it shows us the different stages. So let's have a look at the pipeline in more detail. Cool. So what you see here now are the different stages. So we have our build stage to the left, our test stage in the middle, and our deploy stage on the right. And for each job, you have this kind of like for small panels. And as you can already see, it's stuck, but the stages are run one after another. So at first it has to finish the build stage, then it will start test stage, and then for the last, it will start the deploy stage. But at the moment, it's stuck due to some reason. Let's have a look. And that's a nice thing as well, because by clicking on the job, it will give you some feedback. And yes, here we see this job is stuck because we don't have any active runners. Yes. Stupid me, I just forgot to give this repository any runners or anything so that it can really work on. So let's have a look at the CI settings. We can, again, go through this link, but I want to show you where it is in case you need to find it later. You go to Settings, CI/CD, which is here. Click on it, and you have a lot of options about CI/CD, things you could do. But we now want to look at the runners, because it told us that there are none active. So let's click on it. And then you see what I showed you before as a picture. And here you now see that there are 2 available runners at the moment, but we could create one. So if we would create one, we would, again, click on New Project Runner. It already tells us that there are issues with the versioning, so please don't forget that you would create a Linux one, you can specify tags, and so on and so forth. So just what I showed you before, you could do that. But in this case, we don't want to do that. Oh, got away, because I already created one. So here I created a runner a few days ago, and we will want to enable this for this project. And now we can see it got assigned to our project. And you have now the options. You can also have a look at it, you can edit it, you can pause it, and you can also disable it for the project if you like. Just want to click so that it accepts jobs now. So you can also pause the runners and these kind of things in case you have problems with your system, and all these kind of options without having to remove everything all the time. Okay, so we now have a working runner. Let's have a look again at our pipeline. Cool. The pipeline now realized, oh, nice, my resources are there. I can run this job now. And you can see now how it goes through. So the build job is already finished. It's now working on the unit test. This one waits 60 seconds, so it will take a little while to finish. And then it will go on to the next test, and just will go through all the step by step. So let's just wait a little bit to see if whenever this is finished, just reload in case it doesn't do it ourselves, but okay, cool. It should do it automatically. So yeah, so it should finish this job in a few seconds, I hope so, and then go to the next one and then do the deploy job. In the meantime, what we can do is just have a look at the build job, because, yep, I know it's switched. Can have a look at the output as well. So we can now have a look and see what the runner did. So it created an environment, fetched the updates, it created a fresh repository, and now it runs here the script. And these are the exact 2 lines which this job is supposed to to print. So it just prints compiling code, cleaning code, does some cleaning, and job is succeeded. And this way, it also gives you some insight in case the job crashes at some point. You can always have a look at the output. Just as a note, the output has a maximum file size of 4 megabytes. So in case you have a job which produces a lot of output, you might want to set this to a larger value or try to reduce the output of your job, because otherwise it will just at some point terminate all the output because it can't store anything anymore. And then if it then crashes, you don't know why, because the last few lines are missing or something. So that would be pretty, unfavored. We wouldn't like that. Cool. So let's have a look what the other jobs are doing. Everything's looking good so far. So what's the lint test? Oh, so already finished. I was too late. And yes, so here you can see now everything has passed. So also the pipeline status got a passed flag, and you can see all the different jobs. Everything worked as we thought it should work. That's kind of idea. Cool. So let's change something in the script. So first of all, I don't want it to sleep for 60 seconds. Because it takes too long. Change it to 10 seconds. But because we want to do something, I want to execute a certain script. Of course, the script is not there yet. So I want to create an error right now. But this is what you could do. You could just, with this command, run some script. So the pipeline would then try, after printing and sleeping, to run this script. Again, the syntax is correct. It's pretty nice. Thanks for that information. And I will just update it. I can also, of course, change the message in case for myself, because it makes things easier. But for now, I will leave it just with this standard update message. Cool. Changes has been successfully committed. Amazing. Syntax is still correct. It's very nice. Checking pipeline status. Let's go there. Oops, nope, that's not what I wanted. Sorry. It shows me here now there are just differences. Let's go to the pipeline. And yes, as we expected. So the build job was successful. Of course, we didn't change anything, but the unit test failed. So let's have a look. What happened? So yeah, running test, yes, perfect. It waited for 10 seconds, and then it complained that there's no such file or directory. But that's perfect, because that's what we thought about, what we wanted. And this way, you can also have a look and see if your pipeline is doing things you might, which you didn't expect. And this way, you can also then debug your pipeline later on. So that's very nice. Let's go back and have a look what the rest of the pipeline is doing now. So since the other job is in the same stage, it will execute it. And this time, as we haven't changed anything, it will succeed. But the deploy test, that one doesn't start, because the test stage, so that one, didn't end successfully, because that's kind of like how it works. So it always requires, not necessarily, but in the standard settings, requires that the stage before finishes successfully. So that way, this one job simply doesn't start. We can do it manually. So we can have a look and see it's skipped. Why? And we can also run it. So we can play it manual if we wanted to. So we can also do it then manually, but that's of course something you usually don't want to do on a regular basis. But this way, it already what are requirements for each stage to continue. And it gives you all the information here. Of course, the flag has failed. It tells you which job has failed. Here again, it gives you the output one more time. And the number of jobs, so that one passed, that failed, and so on. So it gives you a lot of information about what you can do. And one thing it also does, it will send you an email about that your job has failed, which is very, very handy as well, because then you already know, oh, damn, I have to take a look and see, probably introduce a new bug to our code. And that's one of the big advantages, because you just merge something, you change something very minor, you thought it is 100%, this is going to work, but it doesn't. And you receive an email almost immediately, and which tells you, no, you're wrong, please check one more time. Very good. So let's go back to the editor, because I want to show you one more thing. Up here, you have this browse templates. I already mentioned it, but GitLab has a lot of different templates for pipelines. So you can go through all of these pipelines and have a look and see what they did there, because maybe if you have a Docker environment, or depending on what you do, this will give you some very good starting point to build your own pipeline. So there are a lot of them. So have a look at them when you set up your first pipeline, and this will give you a lot of additional information, which I think is very handy. So let's go back. One more thing I want to show here as well. This is the pipeline scheduling option. We don't have a scheduling yet, but you will have to think about when you run your pipeline. You can do this automatically at every push, pull, merge request, and so on and so forth. We go a little bit more in detail later. But you can also just run it every day at midnight, for example, and you can create new scheduling here, do a description, internal pattern, or you just define it yourself. So you only want to run it on Christmas, let's say, I don't know, something like that. And you can define everything here. You can also define which branch you're running. At the moment, we only have the main branch, of course, but you can also define if you have multiple branches on which branch your scheduler is supposed to run. And also you can define variables or files, and all these kind of things. So it gives you a lot of options. We will go into details how you implement that into pipeline just in a minute. So yeah, so that's it from the general introduction on pipelines. Cool. So now let's have a look at options you have. So by looking at the pipeline of OpenGadget3, this is the complete pipeline, how it looks like. You know how you have the different stages and different jobs. So we do a lot of different things. So we do config tests. Sorry, didn't get the word one, but okay. Okay, maybe, yeah, okay. Let's ignore it. So you have different config tests, you have node tests, unit tests. We test our SPH formalism, the conduction, and also the gravity. And also we have a long test. In this case, we skipped it, which runs for like 13 hours, just which is a full hydro simulation just to see if it runs through and everything works. So this is kind of like what we have at the moment, but we want to extend it actually because there's so many different modules in the code. So how do you create a job in first place? In theory, it can be anything. As I showed you before, you can use it as a shell. And in my opinion, it's the easiest is to create just a bash script. It could be, but also a Python script. You can use it for system commands, so forth. So like a compile test, which we have here, it sets sources some system. It just builds the code, cleans, and does the next one, and so on and so forth. Or here down below, it runs a simulation. So just anything you could think of as anything you can put into a bash script like you would do on your system, and you just can execute it. That's a pretty nice way of setting these things up. And now we get to the point of what kind of options we have. I already told you about the stages. So we have the config stage, node, unit, the SPH, and so on and so forth. And then what we can do is the next step is we can define resource groups. And this is, in my opinion, very important because pipelines usually run concurrently, so they run in parallel. And this can create issues with resources and also with files sometimes. So it's very handy to define resource groups because that will tell you that only one job can run per resource group at a time. So you can that way serialize your pipeline, because in a lot of cases, it might be that one job depends on the other. So you first want to run that one, which builds the code, then have the next job, which produces some output, and the next job, which will then investigate and analyze the output. And you don't want that for some reason, the testing is done at the same time as the building, for example. That will mess everything a bit up. One more thing which is very important for that is the so-called needs requirement. So you can really tell it requires the other job to finish, or it requires a certain file, or you can be it's very optional. But like that's very, very handy, because that way you can also define, a certain way of doing these things. Then you have, of course, if statements. You can just have a look at the if itself. And you can this way define, for example, if you look at the first block here. So this job here only runs if the pipeline was scheduled and a variable called CPU test is true. And if this is the case, then it will always run. You can also specify this when statement that it only runs when it's manually triggered. It never runs, because that way you can exclude stuff. You can also set a delay option. Or what's also very interesting is that maybe at some point you want to say it's on failure. So it only runs if a job in the previous stage failed, because that way maybe you can have a look or do some additional analysis of that. So this gives you a lot of options on when to run certain jobs. And one more thing is what's also interesting is that the allow failure criteria, because that way you allow a job in a stage or in general to fail, and the next stage will nevertheless start running. Might be handy if your jobs are separate, because that way you can still run the full pipeline and it tells you which jobs failed, instead of terminating when one job doesn't succeed. So this is also sometimes can be quite handy. As you already seen here, I put these statements not in the tests here, but up into some extra rules. And this is very handy, because sometimes you have jobs which kind of like all require the same rules. And then you don't have to put this block here into every kind of job. You can define these rules outside of it. So in these rules, you can do the if statements. You can check for changes. So for example, there are different options. So if a file has changed, then this job should run, for example. You can check for existing. So if a file exists or if something exists, then the job should run, or the other way around. The failure needs I've already explained, and also variables. You can also set variables in there, and you can also get them from your system. So in case you want to work in this kind of manner. And if you have set these rules, so in this case, it's really just when certain jobs should run. So for example, in the last, I don't want it when it's a push. And then you include it to your test via this rule statement, and then you reference to this Hydro rules. So here in this no test, it runs to the stage no test. It has a resource group, so it only one job runs at a time. And it has the rules called Hydro rules. These are the ones up here. And the script is just executing some bash script, which contains all the information about the test. And the next one is the same. One more thing which you also can do is you can define workflow rules, which are like global rules. So you can say, okay, before having to add this to every individual job and so on and so forth, I can just define, okay, my pipeline is only supposed to run at certain points. So for example, here I have an if statement because I don't want it to run at every push. So when the source is a push, it will never run, no matter what kind of job it is. Of course, this now is kind of like a copy from the Hydro rules. I wouldn't need it there anymore, actually, but I have it in there twice just for safety and reasons. So, and here you can define the same rules just on a global level. As you can imagine, this number of jobs and everything, this file might become very large. And one nice thing is that you can split it over different files. And that's what you have here. So you have the workflow, which I already told you, go through that in a second. And you can include these files. These can be local, this can be remote, or some template files. So this means that my main pipeline file includes the CI pipeline, which has all my Hydro tests. It includes the config tests, which are also stored in the GitLab folder. It also has the large test here, and it also includes the IT4I test pipeline, which I've set up. So these are And this way you can also split it, like you have one pipeline for certain systems without having one enormous file at the end of the day. And yes, so one last thing, as you already seen it here, the default for artifacts, as all of these jobs will create artifacts, so log files and stuff. This might clutter your repository over time quite substantially. So I decided here that after 7 days, they get removed. Of course, on the other hand side, having these files gives you more details about the job, why it failed, what it did, and so on and so forth. But on the other hand side, this might create some data for amount of data which you don't want. So let's go through a few last options, I think, which are handy. So the artifacts, which I already showed you. Then there's an option to just in the job, when you have your job, you can set defaults or general defaults. So you want maybe to run something before each job, let's say, loading modules or something. You can define before and after scripts. So run something before or after your job, install software or set back to some sort of default and open a virtual environment or Python environment or depending on, there are a lot of different options. One thing which I think is pretty cool, which I haven't played with yet, but I want to do is that if your jobs are creating some output, maybe some plots, some diagrams, you can upload them automatically to some sort of static GitLab web page. And that way you can also just have a look, what's your stellar mass relation of your simulation at the moment with the given version, and is this still correct or not? And this gives you also how well did the test for the shock tube succeeded, for example, because you can of course do some analysis like chi-squared or whatever to check if it's within some boundaries. But nevertheless, you might still want to investigate it by eye, and this way you can automate this kind of like so that you have the plots available all the time in a very easy manner of the last pipeline. Of course, you can define environments, which you define in your GitLab repository, and then you just tell the job, use that one, for example, if it needs a specific one. Maybe you want to run your software on different environments for the users or something. It might be quite handy. But there are also many others. And I just put the link here for the documentation by GitLab where they go through all of them. It's a bit of a read, but please feel free to have a look at it. And these are just the ones which I think might be very handy and which you might want to use. Okay, yes, we went through this already, but you can set your scheduling as well and define some variables. And if you do so, you have these scripts. So for example, here at the bottom, you see this on development branch, this CPU task runs every day, this one every week, and these are inactive at the moment. But the nice thing also is for the user that you can just easily click on and say like, okay, I want to test this or that, and I only want to only the config tests and so on and so forth. So you can really play with this, and depending on your needs, it really gives you a lot of options on how you want to test, when to test, what to test, because some tests might be longer. You might want to do them at night, short one during lunchtime. I don't know, as you wish. So you're really free in doing these kind of things. And yeah, this is then how it looks like. If everything works as planned, you have a bunch of pipelines at some point going on. Ideally, of course, everything is green, but in reality, we know sometimes something will fail. And this is then how this kind of like is supposed to look like at the end of the day. And yeah, just as some sources, I'm definitely sure that the docs by GitLab are very nice. Sometimes a bit hard to distinguish which version they're using, and they have also some bugs in there, but in general, they provide a lot of feedback and a lot of information on how to set these things up. Okay, so that would be it from my side about the general part. In case you have any questions, please feel free to ask them now. And I'm happy to answer all of them as much as I can. And I hope you enjoyed it and it really helped you to set up your own pipeline at some point.
And I will start with the presentation right away. Okay, well, just let me start right away with a little disclaimer. The solution I'm going to present here is really kind of rough. It's of a sort, it just works. I'm aware of there are professional tools that can handle this. For example, professional tool for handling interaction with supercomputers is called Yakamar CI, which there is a link here, so you can explore it for yourself. The point is, I don't have permissions to install. I don't have super user capabilities at our infrastructure, so I was not able to set it up. But if you want to go, if you have somebody that can set it up for you, I think this Yakamar CI is really a way to go. There are other stuff that can improve and automate and make it more professional, but like for example Jupe for benchmark automations, and I've seen this, and let's say other COEs, they're using these tools already. But for now, for our case at least, I think it's not necessary. We needed to get something up and running really quickly, and so our solution is not using any of these tools, but I highly recommend them if you have a time to implement them and bring them into your project. So give it a try. So the solution that I'm gonna present is based on just several technologies that are fairly standard. So of course you need this GitLab server with where the CI/CD would be ran. This is really standard stuff. You need Bash, you need Apptainer, or it's formerly known as Singularity, which when I was doing just quick search, it can be found on most supercomputers nowadays. You need SSH, Tmux, and some kind of Slurm or some kind of scheduler, Slurm or PBS. But this is all you really need, and you can get this solution up and running without a root permission. So that's quite handy. So the solution is quite flexible and robust, so anyone can tweak it, or you use this sort of ideas to implement any CI/CD they need for their infrastructure. So it breaks down into 3 components. There is a GitLab server, which hosts your code and provides the CI/CD capabilities. Then there is, like already, there is a GitLab runner, which sits in the middle, and then there's your cluster. The solution we came up with can work in case these 3 things are being run on totally different computers. So you can have your GitLab server somewhere, you can have your runner on let's say local machine, and you can have a connection to a cluster. So it can be 3 separate machines, but you need to at least have the connection from GitLab server to the runner, which I think requires HTTPS. And then you need SSH connection to cluster, and you can make it work with a little bit of effort. You can set it up almost anywhere. So when we're what kind of technologies you need for the GitLab runner, you need Apptainer or maybe Docker. You need definitely SSH. Tmux is not necessary, but it's going to come handy. And I don't have to mention Bash. For the cluster, you only need SSH and Slurm, or either Slurm or PBS or whatever scheduler you have there. I think you can make it work with a little bit of effort. So for our case, to make life a little bit easier, we're running these 2 things at the same system or the same computers. So the GitLab runner is actually running on the cluster. In that case, we don't need this additional SSH connection. So it's making our life a little bit easier. So you've already seen a simple pipeline. Yeah. I will start by presenting a simple pipeline that can actually run a job on IT4I infrastructure. I have this simple repository which is a part of Space COE group, so you can have a look and play around with it. So there is a simple source file which has a build script, nothing really complicated. It has a job script which is used to execute the executable, produce some result, and a simple unit test. So this is our setup. And here you already seen this several times today. So this is the pipeline editor. So here I have really just simple CI/CD script, which at this time only compiles the application. So I want to point out a few things. So if I'm trying to run it like this, it's not going to work. And maybe you know why it's not going to work. Maybe you don't. So let me explain. So you see here something about image, very cryptic error. The thing is, our job got picked up by a default runner at IT4Innovation CI or GitLab servers. So one thing I want to stress is I think it's a good idea for you to first of all disable all the default runners that are provided for you. So these sort of cryptic errors won't appear. So you go to settings, CI/CD, in the section runners, and you disable instance runners. So if we now try this pipeline again, it should now get stuck, which is exactly what is happening. And as you already may know, this is due to the fact that there is no runner picking up this job, because by the way I set it up, there's no runner would pick a job without a tag. So this is one thing I want to again emphasize. For each of the jobs, you should provide a tag, and the tag is the way to match a specific runner with a specific job. I set up few runners with this specific tag. So once I tag this pipeline or this job with this tag, it can be picked up. So let's try it now.
Just typo, Barbara.
Oh, thanks. Now you'll be able to see additional nice thing about pipelines. As you may know, these two pipelines got stuck because they couldn't be picked up by any runner, but because they were on the same branch and there is newer pipeline, these got automatically canceled for you. So there's nothing left hanging. here. So now if we go here, we can see our script got executed. We loaded the module and we built the executable. So important thing at this stage, use tags to match your jobs with a specific runners. This is the way I set this up. So there are several runners which run or one cluster, Barbara, and there are going to be another set of runners that are going to be running on different cluster, Carolina, and they will have distinct tags. So by tagging a job, you're sure, or you can influence where the job is going to be executed. So now I'm going to add more stages. Let me use my cheat sheet here. So now we have just a really simple pipeline. We have a build stage where we build our executable. We have a run stage where we run the executable. And we have a test stage where we test the results. So we run it this way. It shouldn't succeed. And this is also something which you might, it's a little bit counterintuitive. So you would suppose that the files that you create in previous stages are kept, but what actually is happening for each job, a new sort of a git clone, the repository is set up into a initial stage. You can see it here. Actually, the executable is being removed just before the script for the run stage is executed. So again, you've seen it today already, the way to go about it. If you need to move data from one stage to another, you can use artifacts. So I wanna keep this this executable from build stage, and at the end of the run stage, I want to keep the result. So this is result. And here. So now the pipeline should succeed. Let's see. Okay. Maybe typo. Yep. So the point I'm trying to get across is that leverage artifacts. They're really a handy tool. As you can see, there are many options which you can set. So you can actually, the way it works is that the GitLab runner actually sends the file to the GitLab itself. So it will get will be stored in a GitLab, so it can be versioned. So it's really, really handy for things like executables. So when something goes wrong and you, for example, lose your data, lose your build scripts, you still gonna be able to recover the executable from the artifacts of the pipelines. So another thing to keep in mind is to really use artifacts if you need to move the data in between different stages. So that would be simple pipeline. Okay, and as you can see now, we're still not using Slurm at any stage because we're running just a small job. But let's see, or we want to be responsible users. So once we need to run anything of normal size, any bigger jobs, we're going to use a Slurm. So let's go ahead and try to modify the run stage script so we can execute a job. So we can do as batch. I prepared already a script, so it's called job sh. Okay. And now we need account. This is specific to a Slurm, so but it can be again easily tweaked for other schedulers. Something which is really handy, you can define variables inside your GitLab. For example, if I go here, I have few variables defined here, which I can use in my job script. And for example, this one is a group variable which holds a current project ID, which I, as a member of the group or administrator of the group, I can change really easily, and it can be used in any project which belongs to this group. So you can take a full advantage. You don't have to care about what is the current project ID. You can just use this variable, and it will work automatically. And I can take care of setting this variable properly. So I also did reservation for today, but this normally is not needed, or the reservation won't be there at all times. So this is just for today. And okay, so let's see if this works.
There's a typo.
Yeah, were.
A reservation.
Oh, thank you.
One more. RE. In reservation.
Now, hopefully I can spell reservation correctly now. So let's see. So 2 stages passed. Final test stage did not. Let's see what was the reason. Okay, so the answer wasn't provided. So we need to go and check the previous job. Although it succeeded. So the sbatch command succeeded, but here the GitLab runner was not able to find this specific file, which means that it simply wasn't there. So when you see something like this, either you have a typo here, or something more, or something different has happened that prevented this file from being created. So what is the problem now? Is that sbatch, as you may know, simply returns immediately, and you can work, and it just sends the job to scheduler, and the scheduler will someday or sometime later will schedule the job for execution. So the way to prevent this from happening, we need to use W in case of sbatch. This will ensure that the sbatch will not return until the job is really finished. So it will block entire pipeline until the job has really finished. So if we try it now, we see that it is working, and it fails. So now we at least know that the problem is not with our test stage, but the problem is actually in a run stage. But what is the problem here? From the user point of view, it still looks like the job executed, or the job was submitted all right, but then it just failed, and we have no information about what type of failure it was. So when I was playing around with it, I did this. And I will explain it in a minute. This is specific to sbatch or Slurm in general, and this is the way to tell the sbatch to put the error log and output log of the job in this specific file. So now we have the logs of the job, and we can cut it at the end of the job. And this way we will know like what is actually the point of failure, or what went wrong. So if I do this, it will, we need to wait for it a bit. But we see there is still nothing printed out, even though we capture the standard error and standard output into this file, and we cut it at the end. There's no printout. It's because the way it works is once something fails, it will just terminate, and entire job will fail. So the point here is that the failure occurred here, and this didn't get executed at the end. Again, I was playing around with it, and the solution that I found for this is if you use something like this. And again, I will explain it in detail later. So this is a construct that tells Bash that in either case, doesn't matter if this fails or it succeeds, please capture the return code. This is a special variable which holds the return code of previous statement or command. So capture this into a variable called RC in either case, and as a whole be successful. Then please cut this job log, and at the end finish or exit the script with the given return code from original SBatch. So this is the way to postpone the failure or success until the end. So now if we do this, there's going to be one more problem. Okay. So okay, now there is actually we can see what is really wrong with the script. So our job log got printed out. This is what it says. It is we are trying to load non-existing module. So now finally we can see what is the actual cause of the error. So we can go ahead and fix it. I prepared already a correct job script, and thanks to all these parts, like capturing the return code, waiting for SBatch to finish, specifying the standard error and standard output file, and pasting it, we can debug these SBatch command or our problems with our job script way better. So with a little bit of additional code, we can make our lives way easier.
There's one typo.
Yeah.
In the correct job. Yeah.
Thanks. Okay, so now we see the output of the job script, and everything looks like it can be successful. And yes, now we were able to spot or and correct the error, and now our pipeline is running. So final thing, for your convenience, I prepared basically a script, wrapper script, which does all of this. So you can just take this. It's called IT4I-CI-SBatch. And we'll do exactly the same thing as below. So you don't have to remember what to put where and why. You can use this for your convenience. So we see the output. Well, you can tell it was waiting for a job to be submitted and finished. So it adds additional command line options plus all the necessary stuff around, so you don't have to remember it. Okay, so this was in a nutshell how you can interact with a Slurm on IT4I. So just to sum it up, the point of this presentation is to show you how you can make your pipeline execute jobs on a cluster. So as I was mentioning, we need several ingredients for it to be actually practical. So we can get or debug or see the errors where they occur, or we actually wait for the job to finish, and so on and so forth. So there's this wait or -w option for sbatch. There's this -o and -e redirection of job output, and this is the construct which captures the return code of the sbatch command. Whoops. And actually cause the failure or success of entire job. So what are the common pitfalls in here? One thing I haven't mentioned so far is the pipeline can fail due to running out of time, because as you may know, the time between when you submit the job and when job starts to get executed can be really long. So you can wait in a queue for quite some time, and by default there is a certain limit of time your pipeline will be running, but you can change it. So I highly suggest changing it to some reasonable number. So you go again, settings, CI/CD, you go general pipelines, and there is right here, there is a timeout, which I suspect something like 72 hours could be reasonable. It depends on you how long you're willing to wait for the scheduler to schedule your job until the job is reported as failed. So this is important, really, because 1 hour, the default 1 hour, is really not enough. So this is just what I mentioned right now and showed you. So set something sensible here for the timeout. Again, you've seen this in action. This is the content of a script, which is called IT4i-CI sbatch. So again, all the necessary ingredients are here. And actually what you provide as a parameters or input command line parameters for the script gets into is expanded in here. So it puts everything around in place. Okay, how is this possible? Where did the command came from? And it's actually coming from a custom container which I prepared beforehand, and this is the definition file of the container. It's a Apptainer definition file, and as you can see here, it's using official GitLab runner from Docker repository, so it's built on top of that. So this I would say it's not necessary if you want to do everything yourself, like I showed you. If you don't need this sbatch CI IT4i CI sbatch command, you can pretty much use the just standard GitLab runner. But I wanted to make the using of the CI/CD as convenient as possible for the users. So I prepared this custom container, and it also allows another thing which I will explain a little bit in detail maybe later. So this is how we are running, or this is the container in which we are running our GitLab runners, and that's why they have this the capability of this script. We can leverage it for convenience. Okay, that's in a nutshell how you would interact with the Slurm and IT4I innovation. Now, as you may know, the pipeline gets is triggered every time in default setting, every time you push into your repository, which may cause running really big jobs every time you do minor changes. So it can lead to a point where you're just wasting resources for every small tiny detail, like a typo fix or minor documentation fix for your repository. You're running entire suite of tests and wasting resources. So when I was thinking about it, I came up with two solutions how to fix this. So if you really have large jobs, it's a good idea to limit them. And the way I suggest we go about it is either use this first rule, and this rule is suited for repositories that are located at IT4I GitLab instance. So these are let's say local repositories, and the other one is more suited for only mirror for the repositories, remote repositories which are only mirrored at IT4I. So I will now just explain a little bit. These are some predefined CI/CD variables. So there's you can read about this. There's lots and lots of variables that are predefined for you, so you can put them together in various ways to create different rules and different scenarios. So how this first is working, this rule only applies for merge requests. So only when you are initiating a merge request, this pipeline would run. Plus, this merge request has to be into a special branch, which this name is, you can choose our arbitrary name, but then you can also need to update this command. So I suggest we can use something like IT4I CI branch, and just to make sure that it's really, this is a merge request that is coming from within the code IT4I. This is our server. So this is only like if you have, for example, you move it somewhere, like you fork the code, or you have some other mirrors that this pipeline won't get triggered for different GitLab instances. So with this rule in place, maybe I can show you how it works. You just grab the rule. And this is again, this is something that I haven't mentioned, but this simply prevents when you have open merge request and you do push into a branch. This prevents something which can happen, and it's basically you would run the pipeline twice, because there is a push event, and also there is a merge request event. So there are two events, so you will run two pipelines, the same pipelines potentially, wasting resources. So this is a good idea to have in place for that case. So now we have a rule here which applies for entire workflow. You can also have these rules, as you see, specified for different jobs. So you can pick and choose and put together a pipeline depending on what type of event and what potentially branch it is. So let's go ahead and commit these changes. And you will be able to see one thing, or you won't be able to see one thing, and it is the pipeline. So there is no pipeline for the commit. So even though I did the commit here with the new version of the CI/CD YAML, there is no pipeline running, and that's because of the rules. So now the only way how to trigger the pipeline is if you actually create a merge request. So I'll try to make a merge request. It has to be from whatever branch into a special branch with a special name that you can choose. And only after I create the merge request, the pipeline will run. You can see it here. Even there's a special symbol for that. You can see here, or maybe special symbol here and special name here. So it's tagged as a merge request pipeline. And you can, this is a very convenient way how to limit the number and frequency of large jobs. So I imagine everyone can set up this branch and they can work on different versions, trying manually. And then once they think they accumulated enough changes to the code, then just to do a merge request into a special branch, and then entire pipeline gets executed. So this is one way how to handle this. The other way is, I haven't tried it, to be honest, but I think it can work. And this is for cases. I don't know how many of you is going to be using this, but in any case, this is for cases when the repository is not hosted by IT4I, but it's just mirrored. And in that case, I don't think the IT4I instance would be notified of merge requests, but it will definitely be notified of push requests. And this is a specific rule which will only be true not when you create a merge request into IT4I CI branch, but only after you accept this merge request. So I imagine you can work on your local GitLab instance. You can again do changes, modify the code. Then once enough changes accumulated, you will create a merge request into this special CI branch. At that point, no pipeline will run at our infrastructure, but only if you merge this request. Only after that, we will see this push. We will see it's in this special branch. This will be true because it will be evaluated by our server, and which is very critical and absolutely necessary is this part, which tells that which actually describes the commit message, which is a part of accepting the merge request. So I will show it to you now. So we have a rule in place. Again, I'm going to commit changes. there is no pipeline running, which is expected. And now we go. Okay. We need to create new merge request. We go from main to our special branch. Okay, maybe now we will trigger. Okay. Now, even though it was open previously, I didn't have to go through like opening it and then closing it. Now, with the new rule in place, by actually merging these two requests, or these two branches, and using the merge request, only after that our branch got executed, and it got executed on the special branch here. Besides previously, unlike previously, we were working on the main. So this is two ways how to limit the number of jobs that are being run at IT4I. Okay, one more time, let me emphasize that this is absolutely crucial for it to work on the commit that comes after accepting the merge request. Also, it's really important if you ever play around with it, the template for this type of commit message, because you can change it. Obviously, there is a possibility in settings to change the template. Then it's up to you to find some string that is common to all commit message that comes from accepting a merge request, and to replace this with your own custom string. So these are two rules. Again, this one is for local IT4I repositories. These are for remote only mirrored at IT4I. One more thing here, this server host equals code IT4I is absolutely necessary. Otherwise, it would be triggered for your own repositories somewhere else as well, which you might not want to. So that was it. These were the rules. So at the end, this is something you can again take advantage of. This is absolutely minimal amount of code to make a sensible CI/CD pipeline for IT4I purposes, or for space COE purposes. It's absolutely okay if you provide build and run and test a job in one script. It might be slightly better to break it down into different stages so you can pinpoint exact problems where that happened. But if you don't want to do that, it's absolutely okay if you just provide one all-in-one do it script. I still suggest you keep some type of artifact as some kind of report. The report from your run, so at least you know what version or what modules you're using, something like that. It could be, for example, a job log from this specific job or something like that. But definitely there should be something you can then search up in the list of artifacts and use and we need to also, it's gonna be versioned in the GitLab, so we can report on it, maybe some kind of speed up or things like that. So I was talking mostly about how to write a pipeline for CI/CD, which can run jobs at IT for innovation. Now, there's a lot of things that come into play. The creating a pipeline is only a one part of it. So this is the list of things you need to set up in order for this to work. So of course you need your pipeline configuration file for your project. That's one thing. But then in our case at least, you need a container with a custom image, which we use for running the runners. We're using Apptainer with the definition file, and the definition file is taking the container from Docker, official GitLab runner image. Then you need to manually set up some limits in your project. Then you've seen this before. You need to create a runner with, I would highly recommend, with a unique tag, which again, these tags are used to match a specific job with a specific runner. So you can control, for example, you can have different set of runners running on one machine and different set of runners running with a different machine. Each of these sets of runners can share a unique tag for the machine, and then you can tag the job based on that, where you want to run it. We have 2 clusters, so we can either tag it for Carolina or Barbara. So then you need to register the runner with a GitLab instance that Gerai already talked about it a bit. Then this is optional, but I would say it's highly recommended. Tweak a bit the configuration of runner. I will explain it a bit later. Also optional, but highly recommended, is using a Tmux for running the runners, because I don't have a super user capabilities. I cannot use sudo or anything like that. And the only way for me to run the runners persistently is to use something like a Tmux. Then you can actually, when everything is set up, you can run your CI/CD. And optionally, there might be need, or it's necessary for you to gracefully terminate these runners at some point, maybe maintenance, or you don't want to waste any more resources, or for any other reason, really. So again, this is the custom container. Really, it only contains this specific command in addition, and also it moves the location of GitLab runner to someplace else. Again, I will talk about it a bit later. This is a definition file. The way it works, you have to have user privileges to build it using Apptainer. So the way this is usually done, you download the definition file locally, you build it locally, and then push it to your server if you want to run it on a server or on the HPC system somewhere. So this is how you should do that. Excuse me. This explains how to set up a runner. There's nothing new here. What I really emphasize again, I'll give it a specific tag so you can be sure where the job is running, by which runner it was picked up. And also, good idea is to use this option, which logs the current runner for the current project. it means that no one else can use your runner, because then you can run into issues where, okay, I have my runner with my specific tag, but somebody can potentially use the tag to make my runner, which runs under my name, under my user, to execute some code, which potentially is a security risk. So again, if you make it private, no one else can make use of that outside your project, of course. No one else can use that runner to run their jobs. So that's a security aspect of it. One thing, again, this is the final stage where after you click create a runner, you will get here. It's very important to not go away from this page immediately, because once you go away from here, you cannot go back. You need at least to copy this token somewhere so you can later use it for registration. So now we're going to talk about how to actually register this special runner, which uses our custom container. So this is our custom container, which we pre-built and push it to our cluster. And you just basically type Apptainer exec custom container.sif, and bin bash is so you can actually explore the container a bit. You can take a look around what's there, what's inside. But to actually register the runner, you can do it this way. You just type Apptainer exec custom container and GitLab runner register. What I highly recommend is giving it some custom configuration file, because the way it works, I suggest some for our case is convenient to keep them in project folder, which is mounted here in /mnt. What you absolutely have to do in that case, you need to provide this bind command, bind /mnt, because by default the container doesn't have access to the mount folder. And if we really want to use the mount as a location for our custom configuration script, we need to provide this bind command to Apptainer exec. Why is this important? If you want to have, again, like I said, different set of runners for, let's say, 2 machines, you want to separate them in a different configuration files, because as far as I know, once you turn on or start to running the runner, it will use the configuration file provided and will actually run all the runners. You can have multiple executors, let's say, in that configuration file, and it would run all of them. So if you just keep default or some single file for all your runners for, let's say, both machines, you will be running twice that number of runners. So all runners on one machine, all runners on the other machine as well. So keep them separated. And that's why this -c or -- config command is useful for GitLab runner. Another thing which I think it's highly recommended is to use a custom build directory. Otherwise, it would be built in, it depends on the runner. In the case of shell runner, is current working directory /build, so it could be all over the place. We at ID for Innovation, we have some quotas on a home directory, so that's why it's also important to use something like a project path here, which has much larger capacity, because otherwise you can use all your space on your home directory really easily for this. Again, if you don't want to use any of these, then you don't have to bind any additional let's say, part of file system, you can omit this custom config toml path. You don't have to tweak the runner description at all. You don't have to use the custom container, but then you would have to do other things yourself, and you can potentially run into risk. So this is a little bit more complicated to set up, but then it's much more convenient for writing and managing the CI/CD. So this is how you would go about starting the runners. So I'm using here a simple script, which is actually doing all the hard work for me. It's starting a new Tmux session with some convenient name. Because I'm running this on our cluster, I need to first load the module Apptainer. Then I can start the GitLab runner by executing Apptainer exec and with our custom container, and give it the command a GitLab runner run and point it to our custom configuration. Now, in order to be able to run Slurm commands from the inside the container, I need to bind all of these different subfolders from the file system. And another thing, because I think we're gonna run into a situation where somebody from a project, some PI, let's say, would be responsible for running all these runners under his name, but the repository will be modified by various people, developers and whatnot. It potentially can be very risky to expose the home for the GitLab runner, because you can basically, from the pipeline definition, you can do anything. You can like remove files, you can move around the file system, and so on and so forth. Because we're running in a container, you can manage this, the visibility, let's say, of the file system or the container. You can prevent these things from happening. There is a level of separation, but because we're again, for the convenience, we want to avoid. We want to be able to access the Slurm directly from the container. We need quite a lot of bind options, which again, this depends on how big of a security threat it is. At the end, it will be ran under the user anyway, so it won't get any additional privileges. So it will be as if a user execute the pipeline. The only problem I see is that different people can run a code as a single user, let's say. So that's why I think this no home is also a good idea. And because of that, there is I need to prepend path as a specific Apptainer variable, which basically does everything all the like it sounds. It just prepends your path with these search paths, so you can find the commands for the Slurm. Because with no home, there are no environment setup scripts that are usually being sourced when you get normal, let's say, login to the cluster. So it might be different at different infrastructures, but it might be necessary to work, basically play around with it and see what you need to set up for it to work properly. So this is the how to run the runners. So you see, this is the GitLab runner run and a custom config, which we specified here. So this is how I'm doing things, and this is how you can just simply gracefully kill these runners. So you can send to the, you have to specify the same session as here, and you can send control \, which needs to be escaped. And this is literally, you need to spell ENTER in your script. This is how it works. This is how you can send control \, which is a signal that causes graceful exit of runners. So this is how to terminate it. So this is just now, because I need this is just minor detail, because I need this user part of file system to be mounted. It basically overshadows the original one. That's why I needed to move it to a separate directory. This is additional complication, but I figured it out that just by simply moving it around and then setting up the prepend path properly, I can have all the security benefits and convenience I need for my runners. So this is about it. So a couple of recommendations, like I already mentioned this, but I really would emphasize using custom clone and build path for the runners, or especially for different runners, so you know what is actually going on. Like I said, you can have different configs for different machines, and you can run one set of runners from one machine and different set of runners from different machines, and they don't get mixed up. Then, depending on where are your custom configs stored, you might need to use additional binds to allow access for the container to that specific part. Use Tmux session for different set of runners. This is really convenient if you're something like administrator or you're responsible for it, and you have sought like quite a high number of different runners. You don't want to run them all in, let's say, one Tmux session. If that goes down, everything goes down. You have better control. So I would also recommend using different sessions for different runners. Making it all work from within the container can be a little bit tricky. Like I showed you, there's few things that need to fit into place. We need to have the special container which moves the executable at first, which is then to not be overshadowed by the custom path or custom bind option that we need in order to access the Slurm. We also then, if we want a no home option for additional safety, we need to use the prepend path and so these sort of hacks. So it was quite tricky to put everything in place, but once I have it in this convenient script, there is really no problem running these runners. The big point, which I'm not entirely sure I have everything figured out at this point, is safety, because my initial idea was that I'm going to be responsible for running a set of runners, and all people from the COE will be able to use these group runners to run their CI/CD. But then I realized that by doing so, I would be running, or it would be as if I was running all these commands. And because I'm member of several projects, which has nothing to do with the space COE, that might potentially poses some security risk. So then I decided to create a runner for each repository, and I will prepare these scripts for each of the partners. So at the end, only thing from the partner's point of view would be to execute the script, and the one who's executing the script will be responsible for all the CI/CD jobs. So with that being said, everyone that has access to that specific repository can modify the pipeline, potentially that it is a safety risk, but the one that I think it's not too much of a security threat, because anyways we share a lot of stuff and we're all sensible people here, I guess. There is no malicious user, I hope not, and in a CI/CD. So I think this is quite okay from a safety point of view. If it is possible, I don't think at our facility it is possible, but if you can create a separate user with very only limited access rights, it could be really nice workaround, or it would ensure safety by default. Again, just a couple things. You should leverage those tags for separation. Separation of the runners, so you know what runner is running where using which tag, and then just by using this tag in your CI/CD, you can target specific runner. At the end, the safety really depends on ensuring that user that creates the pipeline is the user that is running the container, and is not being hijacked by somebody else. So that's about it from my side. There's just a couple of more examples here. There's basically we've been through this, but I wanted to just state it at the end, so you can take advantage of it. I think you should be able to copy it and use it yourself and tweak it. So with that being said, I hope it was useful. I hope you have now idea how to set up your pipeline. I try to focus more on how to set up the pipeline to properly interact with the Slurm, because this is going to be mostly your responsibility. But I also wanted to show for anybody interested how you would go about setting up such a thing at maybe a different cluster or locally or anywhere else. So I will leave it at that. So thank you for your attention, and I'll be happy to answer your questions.